Hello YouTube, welcome back to UbiPsych, and I want to continue our series on the evidence for transgenderism in psychology and physiology. You may know that I have had a series going on this where I've claimed many times there's a huge mountain of evidence. I don't want people to accept that without proof, but people don't want to see a video that's an hour or 2 hours long for the most part, so I'm doing these in small amounts, in threes right now. We'll do 3 here. It's really important just how much need there is for this sort of thing. I've been complaining about it for at least 5 years, that as an active reader of professional journals, I say, why doesn't the public know about these things? It's a consistent problem where you have these journals which are convoluted in their nature, where they're trying to show off how smart they are and all the fancy statistics they know. And some of the best answers to life's big questions are sitting right there: how to better yourself, how to understand the world around you. But people don't really have access to them, and there aren't that many people synthesizing those into reality and saying, here's what this all means. I've read it, and now I take it and apply it. So I want to help provide that role wherever I can. In fact, one of the biggest changes in my life was taking control of my weight and health, something that happened by reading journals, and I found all the answers I needed were right there, just staring me in the face. All these articles showing things they've discovered about how self-control works and about how hunger works. And nobody had ever told me, even in my master's and PhD programs, nobody bothered to tell me a lot of this. Of course, they told me some of it. And taking that and applying it to my life changed it immensely. And then I worked as a coach for a while, taking that same information, and people were just blown away. They're like, this is magic. Where has this information been all my life? And the answer is hiding in journals where no one's aware of it except for the academics, and many people don't have the time or interest to decipher their difficult language. So as I said, I'm going to do 3 articles, and I have a new format. People have been saying, get into the details, show us the sample size, show us the p-values. Okay, but a lot of people don't want to see that. So we're going to cover 3 articles quick, and then you can turn off the video if that's all you wanted to see. What are the findings if you trust me, or if you want to check out the links below. Then I'll go back into each one and talk about it a little more in depth on the nerdier, deeper level, both for those of you that are skeptical or just want to learn more. No offense if you click away at that time, of course. All right, our first study is about cortical thickness in the brain, comparing males and male to female transsexuals. So in both cases, we have people who were born male, the difference being reported identity of gender, and they found many areas had significant physical differences in cortical thickness. Cortical thickness is sort of the measurement from the outside of the wrinkly matter you would see in the brain to where that stops on the inside, and then everything becomes sort of the other parts of the brain in midbrain and things like that. And they've provided a really nice visual here, which I'll make larger for you. And if you see on the left, basically what we're seeing is that where there are those areas that are purple are the easiest ones to identify. Those areas, purple and pink, those are thicker than any of the areas, or than the corresponding area on the right. And so we see that there's more cortical thickness in the male to female transsexuals than the control males. There are some other differences to see there, but for the most part, it's that pattern of more thickness on the right than on the left within that left image. On the right, we see where they've shown where there are thicker areas in transsexuals, which are yellow and orange and maybe even red, as well as they have a legend for blue areas that are larger in the control males. If you're not finding any, that's because there weren't any. And one strength of this study is that if this was just random variation, we'd expect to see some go both ways. We don't. We see just thicker areas in the male to female transsexuals, and those areas are marked with red to yellow, yellow being actually the areas of greatest difference. I don't like to read things to you that you can read for yourself, so if you want to read that figure any further, go ahead and pause. But let's get to the results of the study. They're quite simple, although I will go in more depth after I cover all 3 briefly. Right up here in our results, we can see results. Results revealed thicker cortices in male to female transsexuals, both within regions of the left hemisphere. And they list those regions: orbitofrontal cortex, central sulcus, parasylvian regions, paracentral gyrus. and within the right hemisphere, and they list those as pre and post central gyrus, parietal cortex, temporal cortex, precuneus, fusiform, lingual, and orbitofrontal gyrus. So a lot of areas. Conclusion, according to the authors, these findings provide further evidence that the brain anatomy is associated with gender identity, where measures in male to female transsexuals appear to be shifted away from gender congruent men. So one thing that I'm trying to establish through these discussions is that this is a real physical difference, not some choice, not a psychological problem, although you could always argue that it is. And this helps to establish that quite a bit. What we're seeing is differences in physical thickness of the cortex, which is the wrinkly part on the outside of the brain, for male to female transsexuals versus control males. One really important thing that I will get into more later, but I want to briefly mention here, is all these have some limitations. One is this was 24 of each type, so 48 people total. That's an acceptable sample size, but not enough to end the issue with a single study. And they also pointed out that they didn't control for or select for sexual orientation. So they were unaware of the sexual orientation of the control males, and they had a mixture of heterosexual and homosexual in the male to female transsexuals. They admit that actually we expect some of these differences to result from that. And while it doesn't fully account for it in their mind, they didn't have the sample size to control for those in multiple groups, and they propose a better way to do that. So again, more evidence if you watch all these videos and know that I've got a mountain I may never have time to get through and tell you about. This seems to be what we see time and time again. Yes, there are physical differences in the brain. How did they get there is another question that they're working on. Is it genetic? Is it about hormones? And hormones are interesting because that could indicate that it's something preventable or changeable. Or something else. There is even the idea that thoughts over time can change the brain a little bit. Cortical thickness, probably an unlikely one. I would say unlikely to impossible to be changed just by thought processes, but neural activity and some of the others, maybe. So on that one, we'll leave it there. Stay tuned if you want to see the in-depth analysis of this in a bit. Okay, our second study is about hearing male and female voices and how the brain responds in an attempt to understand and listen to those voices. This makes me think of some, albeit unscientific, things I'm sure you've all heard of, and that is that, say, think of the sex you're attracted to, you might find the voices of that sex particularly nice to hear. I've said things like how much I like female vocals in certain music. Is that a reflection of that? Who knows? And you might hear also ideas that maybe women hear women's voices and men hear other men's voices as maybe challenges or threatening. I am admitting I'm saying all that just from things I've heard people say they've experienced and with no science. One that's more scientific is the idea that women are more attuned to certain noises that could be a baby, and that causes them to have thoughts or hormonal reactions. That one's a little more well established, though I honestly don't know the details of how that's been shown. So just getting you thinking on the right thing here. So we would not be surprised at all that in the brain, when you hear male versus female voices, different parts of the brain activate based on whether you yourself are male or female and whether you are hearing a male or female voice. This study, and I'm just showing the neat graphic to start out, it's actually a really complicated one I'm not going to explain until the end. But basically what you see here is different patterns of brain activation. And for each, they looked at male, female, and male to female transsexual to see if they all agreed or if they were different. And then, of course, who the transsexuals aligned with. Was it their biological sex or the sex they identify with? The answer here was fairly complicated, but ultimately the authors concluded that it supported the idea that even in something like this, which you can't fake or control, the way we process the voices we hear even shows something different for transsexuals. So, that would apply to transgender as well. They tend to say transsexual in the biomedical literature. How did they say it? Well, they said, compared to men and women, male to females showed differences in a neural network, including the medial prefrontal gyrus, the insula, and the precuneus when responding to male versus female voices. With increased voice morphing, men recruited more prefrontal areas compared to women, and male to females while male to females revealed a pattern more similar to women. Again, that means more similar to their identified gender. On a behavioral and neuronal level, our results support the feeling of male to females reporting they cannot identify with their assigned sex. So think about this in a social setting. There's a group of men sitting around, and one of them is male to female, transgendered or transsexual. Men may all respond then very similar to somebody's voice and have a similar experience and go, oh man, I like that, or I don't like that, or that's annoying, that's not annoying, I really find that to be nice, or that's shrill, or that's imposing, or it has gravitas, whatever it might be that someone would say about the voice. That male to female transsexual will probably, in some cases, be sitting there going, I don't think like these people. But switch that scenario to a bunch of women with that male to female person sitting there, and their experience of the voice is likely to be more similar. I am admittedly expanding this out quite a bit. I don't know if it's fully appropriate, but just to give you an idea of why we think this matters. So the classic debate right now is when a male to female or female to male transsexual says, I just don't know how to be. My biological sex is matching gender identity. I am, and I feel, and I identify with those who are this other one, and I want to be acknowledged for that. This is backing that up to say, yeah, they would have that experience, as well as it's probably biological or hormonal in nature, and they have no choice in it, and they're going to experience the world in terms of male and female voices, the way of their gender identity, more so than of their biological sex. It was complicated here, so yes, more with their identified sex, but that's going to make sense because we suspect that it's complicated and that a lot of what is being experienced there might even be somewhere between male and female at times. This study also said something interesting, details at the end of this, but I just wanted to point it out. They cited a study which I will definitely review in another video, but they stated as a known old fact, and the old study was 1994, and I assume it's been replicated, that a range of gender expression and gender identity has been seen in animals as well. So that will be interesting to see. So they think it's really deeply biological and not even unique to humans. So if you have any comments on this or questions, put them below, and we'll move on to the next one. Okay, our third study, I really like this one as well. I had done another video, and one of the studies we talked about was one saying that 63% of transgender people had experienced very, very serious discrimination, and I talked about how that can be an explanation for depression, anxiety, and suicide, rather than this idea that the high rate of suicide in this group of people is somehow an indication that it's wrong or disordered. And let's make this larger for you. This is starting with sort of the big visual picture that people always enjoy. This study talks about intervenable, and those are going to be in the light blue box there, or light blue bordered box. They basically wanted to look at, is there a lot we could do to reduce depression, suicide, and other things? Is it intervenable, as they call it? And on the left inside the circle, you see the things we would say there's nothing we can do for the person at the time we interact with them because it's who they are, where they come from, and what happened to them as a young child. Obviously, the childhood trauma we could do something about, but we're talking about, okay, that's already happened or hasn't happened. But this person may or may not face depression and suicide, substance use, these sorts of things. And the question is, what can we do in between? And they note these general categories of social inclusion, reducing transphobia or dealing with transphobia, as well as transitioning. These are huge issues. I don't want to get into the details right now, but and I'm not necessarily supporting things like that everyone's medical transition should be paid for. I'm not saying it isn't either. Just take that out for a moment. Just the idea is, if we did social inclusion rather than telling people that we won't identify or won't accept their gender identity, or calling them retarded, as Milo's recently done, we instead offer social inclusion. Instead of transphobia, we offer trans acceptance. And again, just to understand if it would help, considering if we offered or allowed, or whatever the case may be, transition. And it even lists social transition. So that's actually what I was saying as well, just this idea of calling someone what they asked to be called, as well as possibly hormones and medical treatment. And the finding of this study probably won't surprise you if you've been watching my videos or if you know the science already. They found that there is a lot that can be done. The quick result here is to say, well, let's say this. First of all, they said among trans-Ontarians, so you can tell where this was, 35% seriously considered and 11% attempted suicide in the past year. And they found that social support, reduced transphobia, and having any personal identification documents changed to an appropriate sex designation were associated with large relative and absolute reductions in suicide risk, as was completing a medical transition through hormones and or surgeries when needed. Parental support was also important, and they go on to give the statistics there, which I'll leave out for now, other than to say that it looks like they did them right and they're fairly strong. And they ultimately conclude that large effect sizes were observed. That's really all you need from this right now. Basically, the question they asked themselves was, can we do something to reduce these negative behaviors and outcomes? Now, of course, they can't answer that for sure, but by saying that there's strong correlations with these things that are changeable, that then we would presume it is fixable and preventable. A bit of a leap there, admittedly, but this is still good science. They found large effect sizes. In other words, the question is, well, if we did what we could, would that help a little? Would that help a medium amount? Would that help a lot? This is indicating it would help a lot. The exact numbers, again, will be inside the document. We'll discuss those a little later. So to summarize the 3 videos of the day, we have biological evidence in the brain of thickness of areas. We have how people respond to gendered voices based on their own gender identity, and that appeared to support what they identified with rather than their physical body. And finally, we have the question of, well, is this something where people who are transgendered are just destined to feel bad about that and have negative experiences? Maybe, maybe not. It's not fully resolved, but it looks like at the very least, we can't just say, obviously this is a disorder or a negative thing you shouldn't do because the suicide rates are bad. It looks like maybe things would be a lot better. Do we know that there would be the same rate of suicide if all societal and medical things were aligned exactly as these people would like? We have no idea yet, but we do see evidence that it is intervenable to a large extent. And so I want to continue my theme here, which is that we need acceptance, and we need to put this in the category of things like sexual orientation and not into more judgmental categories, simply because there have been some bad outcomes. It looks like it's largely due to discrimination, and that this choice to identify as a gender other than natal sex is not a choice. And if it's also not harmful, then we really need to arrive at the conclusion that acceptance, including social transition at the very least, which is to say, call people what they'd like to be called, is the best way to keep people healthy and happy. Thanks for watching, and stick around if you want to see the details. If you don't, thanks for watching UbiPsych, where I see psychology everywhere. Now we're going to get into the good stuff if you're a nerd like me. Okay, time for details on the first study in cortical thickness. One thing I have to sort of punt and just say, if anyone else out there can help or confirm this, they talk about how they estimated cortical thickness, and they talk about they used a scanning technique. This was living people, and then they mapped it onto a sphere, and they did. Can't say if this is the right technique. I need one of you to tell me. It has a good sound to it, but what else can I say? So if anyone knows these sorts of techniques, maybe chime in with if this was appropriate or good or not. One thing I do see is that they cited their false discovery rate threshold, which was Q of 0.05. This is very similar to what people will know as a p-value of 0.05, but it accounts for all the multiple observations that they've made. This shows one of the things that often, when someone says the methodology of the study is weak, they would forget to do something like this. So the 0.05 in this refers to a 5% chance of error. And by default, that chance of error is for a single test. If we just were to look at the thickness of a region for 24 brains compared to the other 24 brains and set that to 0.05, and we said, look, it's different and statistically significantly different, With our threshold set at 0.05, we would say there's a 5% chance though that this was just an error on our part, and we just got some odd individuals, and this is a bad result. But we're 95% sure that this is a real thing between these groups that in the real world would hold true over future study. The problem with a study like this that often leads to the weakness is something where they're basically hunting. People have even called it p-hacking and things like that. That's a little more complicated, but you can only imagine they did hundreds, maybe thousands of measurements. I think in this case, hundreds, maybe even just dozens. I'm not sure. But the more you look, the more likely you are to find what you're looking for, even if it doesn't exist. And we know this, so they account for those things like this false discovery threshold. And in this case, what this would mean is that if they had done, say, 20 brain areas or 20 tests, that happens to be the perfect number to explain this, because when you have 5% chance, that's 1 in 20. And in other words, if you did 20 checks of 20 different regions, we would actually expect very likely that one of them would come back showing a difference, even if there is no real difference. And no one wants to be accused of that. So what they do is they adjust for that and basically make sure each one is held to a higher standard because they checked so many times, taking it down to something where, say they did 500 measurements, then they would take it down to where we would only expect 1 error per 500 or 1 error per 1,000 or something like that, so that in the end we can trust what they're saying, and that the overall result that these differences are real can be said with about 95% confidence. So that's something they did there. They also address matching at the end. It's important that they did this. It's another strength. It doesn't mean that there's no criticisms to be had here. Of course there are some. The small sample size of 24 is not great, but it's good enough. And again, that Q value or P values in general include that. So when they say these differences were significant, it completely accounts for the fact that there is a small sample size. If they had maybe 1,000 people, probably would have seen many, many more differences that were too small to observe in this few people. But the ones they did find aren't particularly suspect just because the sample size is small. That's a common misconception. You would have to attack their methodology to claim it's not valid or that they're lying or biased, like intentionally faking. They did matching here, and what that means, they said age matching. If they had a bunch of people and say the brains, they had one over here that's 24 years old, another one that's 36 years old, and another one that's 51 years old, just grouping those together isn't very strong, because you could say, well, what if the ages are different? So they actually match them. And they say, okay, this 24-year-old and this 25-year-old, or this 24-year-old and this 24-year-old, it doesn't have to be exact, but roughly in the same part of life. We will compare their two brains, find the difference between them, and take that difference as one of our data points. So you get 24 differences between matched pairs, and that is a little stronger. It also, I have to admit, as a statistician, people like to do matching because it actually increases your chance of finding statistical significance. Again, in this study, I think what they found is valid, but I wouldn't be surprised if it was helped or looks a little more robust by doing this, just because the math behind it is stronger. When we match, we sort of say, okay, so these brains are the same other than the male to female characteristic. They're obviously not, but that randomness is accounted for by having 24 is reasonable. More would be better. But they did good research here. In other words, they said, okay, looking, at least they're in the same age, so they should be highly similar otherwise, at least no degeneration or growth things. You can imagine, a 16-year-old's brain is not fully developed, and this should account for those things and make it a non-issue. So that's a pretty good study there. Again, cortical thickness differences, I see no major problem here. And if you look at Journal of Behavioral Brain Science, this isn't something with a particularly strong bias or obvious bias. I'm not saying there is no bias. There's bias in all these journals. And to be honest, yes, it is almost always what they're accused of, left-leaning, if you want to call it politically, if there's a bias. But in the biomedical literature, that's not very strong from what I've seen. It's stronger in psychology and things. So maybe, this one gets selected because of that. And so there's always those concerns of, was there the larger bias happening of maybe 10 studies were submitted that showed there were no differences between transsexuals and non-transsexuals. and they didn't like that, but this one was fun and interesting, so they published it. I try to give them the benefit of the doubt that they're not doing that, but it's a fair thing to think could be happening, and we should consider it. If you're just clinging to that with this many studies and this many journals, well, it's not that great, but it's still something that is reasonable to talk about. Okay, in our second study, I want to keep from taking too long, even though at this point you've signed up for the nerdy stuff. But let's just look at a few of the things here. In this table, they report some of the really important things that they've done right. They do use a corrected Bonferroni 0.125 p-value. That is, again, accounting for multiple tests. So I don't know, they assume they wanted to start at 0.05, and they're basically saying to maintain that over the set of tests that each individual one was actually tested at p.0125, meaning that there was about 1% error allowed each one rather than 5%. And that makes sense when you see several measurements here, but not a huge overwhelming number of them. And they did this in an odd way by my standards, but they used an asterisk on the actual brain region to show which ones had a significant difference, and then they're categorized by what that difference is. So if we look at where male to females differed from men, it's in the A group. That's where we're most interested in saying, look, they're not just men, there's something different in their brain. The first one is the only one marked as significant, so it seems to be this is really where they found something of note. Now, granted, the other ones do show differences, but they're not statistically significant at this strict level. I would guess, for example, the cuneus with a T of 4.43 was probably significant at 0.05, but then doesn't count anymore when we penalize ourselves for testing lots of things. But if nothing else, we can see that in the lingual gyrus, extending to the parahippocampal gyrus, there was a significant difference such that men had more activation than male to females. And we can see that if we look at this once more. They mentioned the hippocampus in there. So if you look at the blue bars, the one in the parahippocampus area, the blue bar on the far right is male to female, the one in the middle is women, and the one on the left is men. So what we're seeing is they're basically saying that blue bar is significantly taller for men on the far left than the one on the far right. And we find women's score is in between those two if we look at the graph here. So that one is well supported as differing from the male controls. There was also evidence of matching with biological sex, such as in the cuneus. And when I say that, it doesn't actually mean matching. So let me just say I misspoke there. This is also differences in the male to female transgender people compared to the women in the study. So not that they did match the men, but that they were also different from the women. So not in accordance with their identity, but somewhere else, perhaps in line with men, perhaps not. And if you'll see, there's three under that. So I'm looking at section B, where it says women greater than male to female. One that's highlighted as the most significant and listed first is the cuneus. So they're saying in that case, the male to females differed significantly from women in that they had less activation. So let's go back over here and look at precuneus. I don't know if it's fair to just look at precuneus and cuneus as the same thing. I believe so, because this shows what they were speaking of. The top left, we can look here at these and see that the activation levels are quite different. Let me look back here quickly to see. This was... And we can see here that women have much more activation, or a change in activation here, that large red bar, although it is in the negative. And we're very different from the other two groups. And that's largely going to be the source of this difference. Now, it is a little more complicated than what I'm saying in that they actually considered the difference between the activation for male versus female. But you can see here that the pattern of responding, those two short little bars for both male and male to female trans, are quite different from the pattern of responding and activation for the women. So here, this one, we're showing less activation for male to female versus women, showing that they don't match with the women on how they interpreted these either. I think I'm going to leave it there on this one, other than to add that they did do something called gender morphing, and they did more detailed analysis on those, looking like this. These numbers next to W and M are how much morphing they did. The W are all women's voices, the M's are all male voices. And the morphing, as I read it, admittedly not every word, it seemed like basically the mixing of all these different men's voices together into sort of one male voice or something along those lines. They did a computerized technique. They did also test the raw voices, which I think is important. I'm always suspect of the computer-aided things that are highly morphed or changed or blended. And they show some of these differences here as well. If you want to check this out some more, here they're looking at sort of the effect that that morphing had. So as you see, I believe 6W and 6M are the most morphed. In other words, all those voices mixed together. And it looks like they get increasingly large activation as a result and differences in activation. So I think they're going to say something about sort of those mixed voices. But to not have this video be incredibly long, we'll stop there on this one. But again, it looks like a good study overall. Very reasonable in the way they did things. They did a good error rate correction. They talked about a Monte Carlo as well. If anybody knows, that's you might have heard of bootstrapping. It's in the same sort of realm as that. They described it accurately and looks like they made the proper corrections. And you might be thinking, well, it's a published article. Of course, I wish I could feel that way, but a common thing to see is major errors in these sorts of studies. If you're seeing any, by all means say so below, because I'm saying these are good evidence. And if you are seeing major errors when you read them yourself or on my screen, please chime in. All right, our third study, you might remember it was, excuse me, it was about intervenable factors. Here there's not as much to look at. Keep in mind, as we said, this, these are correlational studies, and never through this type of study can you prove, but we can infer it and say that it's the next thing to test. Of course, it's really hard to test in humans, so we rely on correlational data a lot. But just to say that if people had a certain experience and then a higher or lower rate, it is likely that that thing is related and could be the cause. So that was what it would say. It's a possible candidate to be the cause. If they controlled for enough factors, you may even say it's a likely cause, but we never leave this saying proven. That's why I want to present all this evidence. There needs to be a lot of this. There is a lot of this, but just this one study wouldn't prove it. It's a strong indication. I want to direct you to the, let's make this larger. That seems to help for readability. The results section, make it nice and large in case you're a small screen. We already talked about sort of just the rate of the problem, 35% considered and 11% attempted suicide. That's a pretty high rate compared to the general population. So what we're looking for is what can we do to get those down towards zero, of course. And they say towards the end where you can see the parentheses kicking in, go back to where that sentence starts and you'll see parental support for gender identity was associated with lower ideation. They don't give a number there, and I think that is something they should do. Then it says lower self-reported transphobia. So that's, in other words, their experience of how much transphobia they experienced. And that was comparing 10th versus 90th percentile. So they're saying those basically in the worst case and the best case. That's what they mean by 10th and 90th percentile. I think the 10% least and 10% most transphobic experiences people have had. Comparing those groups, and for the moment ignoring those in the middle, saying worst versus best situation, this was associated with a 66% reduction in ideation. So if the person in the bad situation, where they were in the top 10% of reported transphobia, had instead experienced the bottom 10%, then, and this is inferring that causation, so I want to be careful here, but we would guess then that their chance of suicide was 66% less. And that is a very large difference. Looking further inside that, parentheses there, we see 0.34, which is where they're getting 6.6. If you do 0.66 and 0.34, that adds up to 1. And they're basically saying the risk in the group with less transphobia was only 0.34 of that in the other group, or 34% of it. And then they give the confidence interval, which is their admission that there's a range that we can be pretty certain there is a difference here. That 34% of the other, or a 66% reduction, is the middle or best guess. And they're saying there is at least as much as, let me rephrase that. There is the actual number, instead of 0.34, might be in the real world as low as 0.17 or as high as 0.67. If it was 0.17, we could round that to 0.2 to say that that would actually be about an 80% reduction in risk of suicidal ideation. If it was 0.67, again, let's round that to 0.7, that would mean that there was only a 30% difference in ideation between the best and worst groups. So admitting that there is a range here, because that confidence interval does not contain 0, we are saying with 95% certainty that this variable matters. How much? Somewhere in that range. Our best guess, 0.34, in other words, a 66% reduction. They found the reduction was even larger, 76%, in suicide attempts among those with ideation. So if you look at only the subset of people who said, yes, I have suicidal ideation, and then looked at how many actually attempted suicide, it was much lower in the group that experienced less transphobia. And here, that 0.24 again goes right with the 76%, if you think of it as 0.76. In other words, if they have only 0.24 of the risk of the other group, then the difference is 0.76 or 76%. And here, although it was a stronger effect, the confidence interval is wider, meaning they're less certain about exactly the size of this effect. Could be as small as 0.07, which would actually be, again, just round numbers, let's round that to 0.1. That would be a 90% decrease in the risk from the group with less transphobia versus that with more. And if it's 0.82, let's round that down to 0.8. It'd be similar to the other. That would say only a 20% difference. And their best guess in the middle of that range is that there was a 76% reduction. I don't like the word reduction because they're actually saying it changed. What they really mean is the group had a lower rate when they were in that situation. And you can imagine there are intervening factors here. So, for example, someone might perceive transphobia that doesn't even exist, and they might be someone of the mind that is also going to tend to be suicidal, because you'll quite certainly be negative if you see negativity where there is none. So those are really good things to say about this. From the numbers, this is fairly undeniable that these two things matter, but we have to think about how did they come to this, because they were self-reported, and we don't know that each of these people are equally sensitive, equally sane, equally observant. Those are just not accounted for here as far as I can tell. So overall, pretty strong. If we put together 10 or 20 studies like this, then the argument's pretty much over. I'm going to keep looking, but right now this is pretty strong. But hold back a little because it's correlational and some wide confidence intervals. So yes, it looks like these are intervenable. We cannot declare that factually just yet from this study. It requires a bit more research. Thanks for sticking around for the nerdy stuff. Please do comment if you liked it, because this took a long time, and if nobody likes it, I'm not going to keep doing it. I'm just going to ask you to trust me and do the minimal details. Critiques are welcome. Did I say too much, too little? Thanks for joining me. I will see psychology somewhere else. Please join me next time.